Need a lot of power for your new ITX build but don't have much room? Corsair's got you covered with the SF750. SFX power supplies are the foundation of any great small form factor ITX build, and with case and motherboard manufacturers continue to push out products that allow enthusiasts to cram high-end core count CPUs into tiny cases, the need for power output will only continue to grow, especially for the ones that want to squeeze out as much performance as possible with overclocking. This need is why the Corsair SF750 is so appealing. Right now, the SF750 is currently the most powerful SFX power supply on the market, rated at 750 watts and 80 plus platinum. If we take a look at the efficiency curve, we can see that throughout the entire load axis, at no point does the efficiency drop below 87%, which is really impressive for a power supply of this size. Previously, if you wanted to break the 700 watt barrier, your only option was to move up to the longer SFXL form factor with the Silverstone SX700, 800, or the newly released 1000. These did have a higher 80 plus rating of titanium, but the longer length made it impossible to use in certain builds. The Phanteks shift comes to mind. It technically does fit, but you'll need to cram the cables right against the case, and that isn't exactly the most ideal situation. The power density to size ratio we're seeing now is incredible, but I can't help but wonder, is 750 watts a sweet spot, or is it overkill? Because if you think about it, the majority of builds that we would even use this in are typically some form of an ITX motherboard, a single CPU, and a single GPU, and that's what we're going to be testing today. But before we do anything, let's take a look at what you get out of the box. The first thing you'll notice when you unbox this is that the cables included are individually sleeved. Yes, props to Corsair on this one because they definitely know their intended market. ITX enthusiasts definitely love keeping their system aesthetics absolutely clean. When I was going through the cables, I noticed that the SF750 now includes two 8-pin CPU power cables, which is great. That means that ITX ports aside, you can now power high-end MATX and ATX solutions as well, which is probably no surprise that Corsair also includes an ATX bracket as well. We can also see a few other of the usual miscellaneous items as well, such as documentation, tie straps, and screws. Looking at the unit itself, we see one 24-pin ATX power connector, four 8-pin CPU PCIe combo ports, and 3 connectors for devices that need SATA or Molex power, and one 90mm fan that is very quiet and doesn't even kick on until you're over 300 watts of power output. With that out of the way, let's run some tests. The first test is a more realistic build. I'm going to be using an ASRock Z390 ITX board with a 9900K, 32 gigabytes of dual channel 3200 MHz DDR4 RAM, and an RTX 2080 Ti. You'll notice that I have 2 stress test numbers listed. One is for Cinebench R20 and one is for IDA64 stability stress test, with Cinebench pulling quite a bit more power. This is probably due to how R20 implements AVX2 and FMA instruction sets. At stock clocks, we idle at 41 watts with R20 at 460 and IDA at 440, so far well below 750. Overclocking the CPU and GPU shows higher power consumption, but still way under 750. Since we're nowhere near 750 on that second test, I'm going to push this power supply even harder. I'm going to be using a full-size X299 motherboard to kind of simulate an ASRock X299 ITX build and see if we can get to the limit. This system is going to be using an Asus Deluxe board equipped with an 9980XE, 64 gigabytes of quad-channel 3000 MHz DDR4 RAM, and of course the RTX 2080 Ti. I made a build video on this system a while back, so if you're interested, you can check it out by clicking the link at the top. So at stock clocks, the numbers look really good. The SF750 handles this workload without a problem. But even at stock clocks at 690 watts, we're already at 92% of the total rated capacity of this power supply. So if you're thinking there's no way that we're going to be able to overclock this, well, you'd be right. Overclocking the CPU and GPU, then starting the stress test ended in complete failure. The power supply pretty much tripped instantly and shut off the computer. Knowing that we've gone over the limit, I wanted to see by how much, so I threw on the Corsair AX860, and even with this, I was pretty close to maxing that out as well. So looking at the total wattage used between the two tests, I'm gonna say that the SF750 is quite a bit of an overkill today, unless you're planning on going with a really power hungry part. For everything else, the SF600 is sufficient, and that includes overclocking Intel's 9900K and AMD's 3700X with the RTX 2080 Ti. You technically could go as high as AMD's 3900X, though at a more moderate overclock on both the CPU and GPU, because you want to avoid spiking over the 600 watts. I know a lot of you are going to come out and say that you should always have a 20% buffer, so with the SF750, my continuous load should be around 600, but this simply isn't true. Power supplies are capable of running at the rated wattage. That means that the SF600 can and will run up to 600 watts without any issue. While you do want to be slightly under that since you don't want it to spike over, budgeting for an additional 20% really isn't necessary unless you plan on expanding your system, which in an ITX form factor isn't very likely considering the space constraints. I think this 20% assumption may have stemmed from the confusion about the efficiency curve of a power supply, especially before the 80+ ratings became a thing. But power supplies are so well made today that this isn't really an issue anymore. I work closely with power supply vendors for deep learning applications with workstations and servers at my day job, and I've been reassured that as long as the power doesn't spike over the rated capacity of a power supply or the total load of a particular rail, high utilization is not a problem. And after seeing most of these compute nodes train at near 100% power utilization continuously for weeks on end, I believe it. Since we're on the topic of utilization, another thing to consider is the likelihood that you're even going to max out both the CPU and GPU at the same time. How often and for how long? For my overclocked 9900K configuration I used in this video, while gaming and editing videos, I go nowhere near the 600 watts. And to be honest, 90% of the time, I'm either on YouTube or browsing Reddit. And while I'm confident in saying that you probably won't run into any issues running full tilt, if longevity is your concern, Corsair does have an amazing 7-year warranty coverage on all Platinum Series SF power supplies, which includes the SF750, the 600, and of course the SF750. So while the SF750 is overkill for the majority of ITX builds today, it doesn't mean that it's going to be the case tomorrow. With AMD pushing the boundaries and bringing high core counts to the masses, I wouldn't be surprised if we start wondering when the next 850 version is going to be available. What do you guys think? Do you prefer saving a little bit of cash, running the exact power supply capacity you need, or would you spend a little bit more and have that overhead for peace of mind? Let me know in the comment section below. And that's it for today. Like, subscribe, it really helps me out, and I'll see you guys next time.